All right, so today we are doing 9.3, find special products of polynomials, page 569 in your textbook. And the good news about today's lesson is that it is pretty much the same as 9.2 in that we are still multiplying polynomials. The difference is we are taking it a little step further, and you'll see that in the examples that we do here and that you do in your work that they are written a little different, and that they follow the same format basically. But once you really get past that part, it's still multiplying polynomials using that FOIL method, FOIL, first, outer, inner, last. Okay, so I'm going to throw a few examples up here. Hopefully this isn't too long of a video, and I think we'll be able to catch on pretty quick, and you can get to your work and get done. So I'm going to be on 569, the very bottom where it says guided practice. I'm going to go through those examples real quick, not too quick hopefully. Again, pause the video, replay if you missed something, and rewatch these if you need to. But I think if we were okay last week, I think we're going to be okay today as well. So for example, the first one says x plus 3 squared. And it's not x plus 3 squared, it's x plus 3 squared. We are squaring or raising the entire quantity, the entire expression to the second power. And so when it says find the product, all we're doing is exactly what it says. We are squaring that. X plus 3 times the quantity x plus 3. That's what that is. And now I can use that FOIL method that I told you about to simply find the product in a polynomial expression. So again, let me get a different color here. So first would be x times x. That's not 2x, right? That would be x plus x. X times x is x squared. And then that one, x times 3 is 3x. So it's plus 3x. And I know it's plus because it's positive. Even though I'm multiplying them, I still follow the same sign that's there. And then the inner, that was the first. The outer, the inner, again, 3 times x. So plus another 3x. And then the last, 3 times 3, of course, is 9. And then I'm just going to combine my like terms. So x squared, 3x plus 3x is 6x plus 9. There it is. X squared plus 6x plus 9 is the product of x to the third, or x plus 3 squared. Okay? All right, let's do another one. The second one, 2x plus 1 squared. 2x plus 1 squared. So that's 2x plus 1 times the quantity, 2x plus 1. Okay, so 2x times 2x is 4x squared, right? Because 2 times 2 is 4. X times x is x squared. 4x squared, and then 2x times 1 is 2x. 1 times 2x is 2x. 1 times 1 is 1. Remember, we're not adding these. Even though it's a plus sign there, I'm multiplying them because remember, this is the multiplication there. But it's positive 1 times positive 1, which is positive 1, right? So that would give me 4x squared. 2x plus 2x is 4x plus 1. There it is. Again, I cannot simplify this any further because I have nothing here that is like terms. X squared is not the same as x, so I cannot combine. I can multiply them, but I cannot add them, so I cannot combine that or reduce that anymore. So 4x squared plus 4x plus 1. All right. And let's do 3m plus n squared. So 3m plus n times 3m plus n. Same exact drill. 3m times 3m is 9m squared. 3m times n. Oh, this is interesting. What is 3m times n? It is 3m n, right? Because this is, there's a glare there, maybe. Because this is the same Okay, this is the same as 3m times 1n, which is 3m 1n, or 3mn, okay? So don't be thrown off by that. So 3m times 3m is 9m squared, 3m times n is 3mn, plus n times 3m, same thing, just reverse the order, but that's okay because you can do that in multiplication. So n times 3m is also 3mn. And notice how I kept the order of the variables the same. Mn is the same as nm, so it's still 3 times m times n. I could even write that as m3n. It's still the same thing, okay? But just to keep it all easy and uniform, we write it the same way. And then n times n is n squared, all right? So 9m squared, these are like terms, 3mn plus 3mn. Well, 3 plus 3 is 6. Mn plus mn is 3. It's the base. 3mn plus 3mn is 6mn, just like 2x plus 2x is 4x. It's the same thing. Again, we're not multiplying, so it's not, if we were multiplying these, it would be 9m squared n squared, but we're not multiplying them, we're adding them, so that's why that stays the same. And then plus n squared. So 9m squared plus 6mn plus n squared. That is the product of 3m plus n squared, written as a polynomial. Okay. All right, let's see here. That might just about do it. I just want to check one more thing here. On the next page, you will see an example like this. I'm on page 570, number 5, where it says x plus 10 times the quantity x minus 10. You'll see some of these. So that will give us x times x is x squared. X times negative 10 is negative 10x. 10 times x is positive 10x. 10 times negative 10 is negative 100. Pay attention to your signs, okay? Notice how I didn't just have addition signs all the way through because there's a negative there. So when you're multiplying these, if it's a positive times a negative, it's going to be negative. If it was two negatives, it would be a positive. So pay attention to that. And then x squared, negative 10x plus 10x, well, that cancels to give me 0. Those cancel out, minus 100. So this one is x squared minus 100. That is the product of x plus 10 times the quantity x minus 10, is x squared minus 100. Another example that may be similar to that would be x plus 3y. This will be our last example here. X plus 3y times the quantity x minus 3y. Keep those y's the same there. So x plus 3y times the quantity x minus 3y. So x times x is x squared. X times negative 3y is negative 3xy. You could also write negative 3yx if you wanted to. It's the same either way. I just kind of did it in alphabetical order there, but whatever. So x times negative 3y is negative 3xy. Positive 3y times x is positive 3xy. And then 3y times negative 3y is negative 9y squared. Again, because I'm multiplying. 3y times negative 3y is negative 9y squared. Okay, and so that can simplify a little bit. Negative 3xy plus 3xy cancels to give me 0, leaving me with minus 9y squared. So x squared minus 9y squared. Okay, so go back through the video if you need to look at those examples a little more in detail. If you absolutely have a question that this video does not address, please feel free to call me or text me, and maybe we can set up a private Zoom session if you need some more help in that way as well. All right, but go ahead and get started if you haven't already, and let me know if you have any questions or concerns. Thanks, guys.